Right, we're ready for page 4 of the 7-2 notes. We're going to continue finding equations of lines, and we're going to look at how to do that if we're given information about lines being parallel or perpendicular to another line. So, just for some review, if we have two non-vertical lines that are parallel, then they have to have the same slope. Remember that parallel lines have the same slope. The reason we say non-vertical lines because if they're non-vertical, or if they are vertical, the slopes are undefined. So, perpendicular lines. Two lines, remember, if they're perpendicular, the product of their slopes is -1. Again, what you probably remember, or what may help you a little more, is to remember that the slopes of the two lines, if they are perpendicular, are opposite reciprocals of each other. Okay? So let's jump right into finding an equation of a line if we know some information about it being parallel or perpendicular to another line. So in this example, we're told that a line, we're trying to find an equation of a line, and this time it says both in slope-intercept and in standard form. Which is okay because we actually find slope-intercept on the way to standard form, so it's not any more work than what we did before. We're told that the line passes through this point, 2, -4, and it satisfies these conditions. So these are really two problems. First problem, we're going to say, well, it's parallel to this line, 3x plus 2y equals 5. Well, it'd be nice if we knew the slope of this line, so we would know the slope of the line we're looking for. Because if it's parallel, we have the same slope, right? So let's rewrite this equation in slope-intercept form so that we can find the slope. To do that, we need to get y by itself, right? So I'm going to subtract 3x. So we get 2y equals -3x plus 5. So I've subtracted 3x from both sides here. And then to get slope-intercept form, I'm going to multiply by 1/2. Alright, so we get y is equal to -3/2 x plus 5/2. Alright, so that's the slope-intercept form of this line that we were given. Now what we're told is to find an equation of another line that goes through the point 2, -4, that happens to be parallel to this line. Well, if it's parallel to this line, then the slopes have to be the same. So for our line, what we know is the slope should be the same as this slope. So the slope is -3/2. And we know it goes through this point. It has a point 2, -4. So if we know the slope, and we know a point that it goes through, we can start with point-slope form. Point-slope form is useful when we have a point and a slope, right? So point-slope form, just to remind you, is y minus y1 equals m times x minus x1. So let's start there. So we have y minus -4 is y plus 4 equals our slope, -3/2 times x minus 2, right? That's our point. Now, to get slope-intercept form, we need to distribute the -3/2 and then subtract 4. So y plus 4 equals -3/2 x plus -3/2 times -2 would be what? That would just be 3, right? So plus 3. Okay. And now we need to do what? Let's see. We need to subtract the 4 from both sides. Do that. So y equals -3/2 x. Subtract the 4, we get -1. So there is our slope-intercept form, right? So this is slope-intercept. I'm about to put slop, but it's not slop, it's slope. Again, I don't know if I gave you enough room here. If you write big, you might not have enough room on this page to do this example, so you might need another piece of paper. Alright, so that's slope-intercept form. We're also asked to find standard form. To find standard form, we're going to get all our x's and y's on one side. So I'm going to add the 3 halves x. It gives me 3 halves x plus y equals -1. And then we have to clear the fractions, right? So I'm going to multiply everything by 2, since 2 is our LCD. Multiply both sides by 2. So we get 3x plus 2y equals -2. Alright, so that would be standard form. The coefficient of x is positive, so we don't have to worry about that. This is standard form. So we found both slope-intercept and standard form. Okay, so we're ready for part B. So now let's assume, rather than being parallel, let's say it's perpendicular. Well, if it's perpendicular to this line, we already changed this line to slope-intercept form to find the slope. The slope was -3 halves. So in this case, our line, if it's perpendicular to this line, would have a slope not -3 halves, but the opposite reciprocal of -3 halves, which would be a positive 2/3, right? So positive 2/3. That's the opposite reciprocal of -3 halves. Okay. So now we know the slope of the line we're looking for, and we still know it goes to the point 2, -4. Alright, so we know a point, we know the slope. Let's use point-slope form. Y minus -4 is y plus 4 equals slope 2/3 times x minus 2. That's our x-coordinate. That's point-slope form. We're using that on the way to slope-intercept form. I'm going to distribute the 2/3. So we have y plus 4 equals 2/3 x minus 4/3. And then I have to subtract the 4 to get my slope-intercept form. So subtract 4, subtract 4. I'll write that up here. Let's see. So we have y equals 2/3 x and -4/3 minus 4. Well, 4 times 3 is 12, right? So 4 is really 12/3. So -4/3 minus 12/3 would be -16/3. Alright, so now this is our slope-intercept form. It's y equals mx plus b, right? So that's slope-intercept. We're also asked to find standard form though. So we got to move all the x's and y's to one side. Subtract the 2/3 x, that would give me a -2/3 x plus y equals -16/3. Alright? And now we have to clear the fractions and make sure the coefficient of x is positive, because right now it's negative, isn't it? So if we multiplied everything by 3, it would clear the fractions. But in order to get that coefficient of x to be positive, I'm going to multiply everything by -3. Alright, so we distribute the -3. What do we get? So we get a positive 2. So we have a 2x. -3 times y would be -3y. And -3 times -16/3 would be a positive 16. Okay, and that would be our standard form. Now when there are a lot of steps like this, you could always check to make sure some things actually work. You could plug in the point 2, -4 to your final answer to make sure it really works. So 2 times 2 is 4, minus 3 times -4, that is 16, isn't it? So you could plug in that point. I could plug it in up here also. 2 times 3 is 6, minus 8 really is -2. So yeah, if you plug in this point to your equations to make sure they work, that would be good. Alright, so one extra step if you're told something about parallel or perpendicular, find the slope of the line you're given and figure out how your slope is related, find out your information for your line, and then go through the same process. the last thing we have is an application. I think I put a couple of these in your MyLab work as well. So this gives you some data on tuition and fees for in-state students at public four-year colleges from the years 2005-2010. The scatter diagram was made, and we're going to say, well, this is approximately a line, not exactly a line, but it's pretty close, and so we're going to try to use a line to predict what will happen in the future from this data. Of course, I know this is pretty far in the past, but we're also given some other information just to make the numbers a little smaller. We're going to let x equals 0 represent the year 2005. So we're putting an x here. That would be 0. X equals 1 represents 2006, and so on. So we're actually told what points to use. 1, 5804, that's from this year 2006. 4, 7050, that's from this year 2009. So we're actually asked to use this point and use those 2 points as an approximation for the line. So if I draw really a picture here, what it looks like. So we're going to assume that line approximates this trend in the data. Okay. We're asked to find an equation of that line. It doesn't tell us what form to use. I'm going to just use slope-intercept form. I think it would be easiest to use to find part B. So we're given 2 points, really. Before we find an equation of a line, we need to find slope, right? To find slope, we subtract the y, so 7050 minus 5804 over 4 minus 1. Let's see. All right. So let's see what 7050 minus 5804 is. 7050 minus 5804 happens to be 1246. And this is 3. Alright, so it's not really a pretty number. If we divide, we get a repeating decimal. In fact, so here's what we get, right? Yeah, so I'm just going to leave it like this. Alright. The fraction doesn't reduce. You could try to reduce it, but it doesn't reduce. So we're going to leave it like that. So that's the slope. To find the equation, then, I'm going to use point-slope form. I could use either one of these points. I'm going to use this one, x1, y1. So we have y minus 5804 equals our slope, 1246 over 3 times x minus 1. Okay. So let's see here. I'm going to distribute, right? So we have y minus 5804 equals 1246 over 3 times x minus 1246 over 3. And then we're going to add 5804 to both sides. Add 5804. Right? And then we should get an equation in slope-intercept form. Since we're not told what form to use, I'm just going to leave my equation like that. So y equals 1246 over 3, right? 1246 over 3 times x. And let's see what this, I'm going to use a calculator for this. So I have negative 1246 over 3, and I'm subtracting 5804. All right, now your calculator, even though I used fraction operations, gave me a decimal answer. And that's okay, because we're doing a real-life situation. Most likely, in this case, you'll be asked to round to the nearest dollar or maybe to the nearest cent. It just depends on what you're asked to do. I'm going to round these things to the nearest dollar. Okay. Now, do we really care about that 33 cents if you're paying thousands of dollars in tuition? I don't know. And it's an estimate anyway. We're using an estimated line. It's not really fitting the data exactly, so it's just an estimate. So rather than the fractions, let's actually use to the nearest dollar. So we take 1246 over 3. And again, MyLab may ask you to round to the nearest cent. I don't know. Just pay attention to the direction. So 1246 divided by 3 is $415.33. So I'm going to say that's about $415, right? $415 times x. And then I'm going to do this part again on my calculator, so 1246 over 3. And I'm going to, and that's a negative, right? So negative 1246 over 3. And then I'm going to add 5804. So that's 53. So this is what I get here. Let's see. I get this guy right here, right? So to the nearest dollar would be 53.89, right? So 53.89. So this is an approximation. That 53.89, what that represents is your y-intercept, right? So it should be where we cross the y-axis right here, about 53.89. This looks about right. Okay. 415, that's a slope. That's how, on average, how much we're increasing. Tuition is increasing each year from this table here. Okay, so this is a good estimate in slope-intercept form. Now, the reason why I like slope-intercept form in this case is because we can use it to predict things, and it's much easier to predict with slope-intercept form than it is with standard form. So we're asked to use the equation from Part A, equation we found, to predict the cost of tuition and fees at public four-year colleges in 2012. Well, let's see. 2010, let's see. 2006 is 1, 2007 is 2, 2008 is 3, 2009 is 4, 2010 is 5. 2011 would be 6, and 2012 would be 7, right? 7 years after 2005. So we want x to be 7 in this case. All right? So we use our line, and we basically plug in 7 for x, and we can figure out a prediction for y. So y is equal to 415 times 7 minus 5389. So let's plug that in and see what we get. 415 times 7 plus 5389. And we should get 8,294. All right, so that's how much someone in 2012 would expect to pay for tuition and fees at a public four-year college. So that would be a good prediction to the nearest dollar. All right, we're done with section 7.2 finally, and we'll move on to 7.3, which 7.3, 7.4, and the rest of it should go a little quicker.